class again. In this class, we start a new topic which is also relevant to derivative of a function. Actually, mostly I have discussed in the previous class which is relevant to derivative of a function, and I have also discussed different types of function and its derivatives. But in this class, we discuss some specific types of derivatives of a function. Actually, these are all functions, but some different patterns and some different ways to solve them. Have you understood? Now I will start. First of all, what is your topic? Your topic name is derivatives of determinant. Derivatives of determinant. How can you differentiate if given expression or if given polynomial or if given any function is in the form of determinant, then how can you differentiate given expression or given function? First of all, I want to give you simple logic. Suppose that I want to take a determinant A which will be sin x, cos x, tan x, and another will be e to the power x, log x, root under x, and another function again will be x square plus x cube, and final function will be x to the power 1 by 2. These are the functions that will be represented in terms of a determinant. Now we have to determinant this determinant. Suppose this determinant is named as fx, and you have to find as f dash x. In that case, how can you find derivatives of these functions? That means derivatives of this determinant. Definitely you will tell me, sir, simplest way you have to firstly find the value of fx, that means determinant of a, and obtain the value of this determinant. You have to simply differentiate, but it becomes definitely lengthy, and sometimes also definitely you will fall in trouble due to complexity, because definitely its calculation will be sometimes more complicated when given function or given polynomial is more complicated in this form or different kinds of function. So now here I want to discuss some tricks. That means not a trick, actually this is also a concept. This is also a concept, but a specific procedure through which you can solve easily these patterns of portions or these kinds of a problem. Now I want to give you some, first of all, some rules or some property through which you can easily differentiate any function which is expressed in terms of determinant or as a matrices. That means simply determinant form, not a matrices. I think you understand very well. Now I want to give you first of all theoretical portion of it. Thereafter I will again take its relevant problem which is also present in your books. See here. Firstly write here theoretical function, theoretical portion. Later, I think you also know about, definitely you have already studied about determinant and property of determinant, because sometimes it will be helpful to prove different kinds of problems, and sometimes it will be also easy to solve these kinds of problems. So I will suggest you, if you have not studied about determinant, I will definitely here I will again help you, but before it, if you have already studied, try to at least half hour try to study in detail, mainly its property, otherwise no need. See here, let fx is a determinant, let fx is any determinant, or if you want to suppose in terms of a, you can also suppose, because most of the guys knows about it, it is also represented as this way, but as you know that its value will be definitely after manipulation. If you find a value of determinant, that means after manipulation, definitely its value will be a specific, either sin x, cos x, tan x, or x to the power 2, or under root x, or any constant value. So I will tell you, don't bother by taking it, because definitely obtained value will be any function. So I want to also suppose just as a fx. Suppose that this is determinant is a 3 by 3 matrix, maybe 2 by 2 or 3 by 3. Here, this is your f1x collection of, this will be your f2x, while this will be your f3x, and this will be your g1x, and this will be your g2x. Here will be g3x. Here will be h1x, it will be h2x and it will be h3x. Now I want to tell you, now suppose that you have to find that f dash x. How can you find f dash x? Suppose that if this fx, that means this determinant is easy to express or find the value of this will be easy for you, definitely you can do. Definitely you can do easily. Suppose that there will be x, there will be 1, 2, or maybe x square, x, as like if there will be a function, you can differentiate easily. But suppose that there will be complex function, do not try to go through simple way. That means simply evaluate its value and differentiate. It will be more complicated for you. So I will again tell you, when given function is in more simpler form, you can firstly determine the value of fx, value of this determinant. Thereafter you can differentiate. But if there is the given function is more complicated or more complexity in given your problem, try to firstly here in that case do not try to go to solve through simple procedure. That means simply determining the value and solve that function, obtain function. Do not try to by this way. In that case, try to go. I will discuss a particular specific property to differentiate given function as it. Now, I want to give you first of all its theoretical portion. If f1x, f2x, f3x, as you know that this fx is differentiable. Fx is differentiable only in that case when f1x, f2x, f3x, fg3x, g2x, g1x, h1x, h2x, h3x. Individually all functions should be differentiable. In that case you can differentiate directly. Now I want to give you again its theoretical portion. If f1x, f2x, f3x, h1x, h2x, h3x, g1x, g2x, g3x, you can write and g3x are differentiable, then if f1x, f2x, f3x, g1x, g2x, g3x, h1x, h2x and h3x, all these functions are differentiable individually, in that case you can differentiate using this property about which I will discuss here. See here again, in that case f dash x will be determinant of firstly you have to differentiate first row function and remains function will be same. Right here, firstly differentiate f1x, that means f1 dash x, f2 dash x, third will be f3 dash x. Here will be g1x, g2x, g3x. Here will be h1x, h2x and h3x. This will be your first step. That means firstly differentiate first row all functions and remains function will be same in determinant. In second part, there again you have to take first row and third row same and differentiate second row. In that case you have to write here f1x, f2x, f3x and differentiate the second row function, that means g1 dash x, g2 dash x, here will be g3 dash x and here will be h1x, h2x and h3x. I think you understand very well. This is your second part. Now I want to write here third part. Actually there is no space, so I want to write here this part, and third part will be plus. See here. Now in second step you have to take same first row and second row and you have to differentiate third row in determinant. For that means f1x take constant, f2x also and f3x also same. Similarly g1x, g2x, g3x and in final stage you have to differentiate h1 dash x, h2 dash x. I think you know about it. I have already discussed many times derivative of any function, that means derivative of dfx dx is also denoted by by symbol dash, that means f dash x or dfx dx. both will be same. There will be h1 dash x, h2 dash x, h3 dash x. This is your third portion, the third part. That means f dash x. That means if you have to differentiate this determinant, then firstly differentiate first row function and take remains same second and third row function. Again differentiate second row function, take remains same first and third row function. And in third case, in third part, third row differentiated all those functions, and first and second row functions will be taken always constant. And this way now you have to evaluate this determinant, and this determinant, and finally you can calculate. That means after now you have to find determinant of this function, determinant of this function, determinant of this function, and finally you will get its correct answer. Now you will again tell, sir, it will be also more complicated because I have to again find the determinant of this, determinant of this, determinant of this. But here this is only, but you can here we need only find single determinant and then after it will be easy. But this is not true, because if given function is more complicated, as suppose that after multiplication definitely you will get sometimes, as suppose that there will be sin x, there will be x square, there will be e to the power x, definitely you will get as form e to the power x into x square into sin x. In that case you have to apply product of three functions for differentiating. So I will in that case again take a log on both sides, and definitely you will again proceed to find the dy dx, that means derivative of that function. So I will again tell you, while given function in determinant form is more simpler, then you can proceed by firstly try to simplify, that means determine the value of the determinant, thereafter you can differentiate. But if you get given function is more complex form or more complexity, that means given function is more complicated after evaluation, then try to go always through this property. I think you understand very well. Now if you understand, then I will take some questions for these topics such that you can also again understand very easily. See here, next question will be for you. Suppose that fx is equal to question 51. Suppose that fx is equal to determinant of x square x to the power 3 1 2x 3x square 1 2x 3x square, and the third function will be 0 to 6x. I think you understand. Now you have to find f dash x. Find f dash x. How can you find f dash x? Now I will again tell you, actually this function is more very easy. You can differentiate after finding the value of this function, but I will suggest you don't go by this way, because sometimes if you do if you solve all problem by simple method, definitely when you get complex functions or complicated function determinant form, definitely you will try again go through that method, but you will, in that case you will forget this property. So I will suggest you, this will be very easy for you. So I am always telling you, try to go theoretical by lengthy method, that means about which I have already discussed here. So I will suggest you, firstly you can write here f dash x is equal to derivative of this function. You can write derivative of this function 1, derivative of this function 2x, derivative of this function 3x square. I think you understand. And remains same of second row 0 to 6x. I think you understand. Plus again take here derivative of this will be x square x cube, derivative of 1 will be 0, derivative of 2x will be 2, derivative of 3x square will be 6x, derivative of this will be again same. I think you understand. Now in third step you have to take first and second row same, x square x cube 1 2x 3x square, and it will be 0 to 6x. Now you have to differentiate this function. In that case it will be 0, this will be 0, and derivative of 6x with respect to x will be 6. Now you have to find its value very easily. Now you can see here both row, that means 0 its ratio will be 1 upon 2x. You can go through any row or column, but I will suggest you its determinant value will be, if you find its value, it will be 0. How can you find it? I will, actually there is no space, still I will try to solve it. See here, firstly go through this row, this will be cancelled, this will be 12x square, and this will be 6x square. That means 1 into 12x square minus 6x square. Now see here again. Now sorry, don't go through this way. Sorry, I have not seen here. Simply see here, first row and second row is same. I think you know about property of determinant. If any determinant, suppose that this is your first row and this is your second row and this is your third row. If ratio of two rows for each corresponding entry will be same, that means suppose that there will be A, B, C, there will be 2A, 3A, 3B, 2B, 2C. In that case, if you take ratio of first row and second row for corresponding entries, that means A by 2A will be 1 by 2, B by 2B will be 1 by 2, C by 2C will be 1 by 2. In that case, its determinant will be always 0. So you can write here directly 0. Why? You can write separately its its property. Why have I taken its value will be 0? So its determinant will be 0. Why? Because second and first and second row is common. You can say that, or you can also tell me, sir, its ratio of first row entries and second row entries correspondingly will be constant. So its determinant will be 0. If you go again in third row, here you will get x. In that case, second row and third row will be again same. So its determinant will be again 0. And if you take a third part, here you have to simplify. This will be in that case it will be 6 times 2x square minus x square. Here if you calculate again, 6 times 2x square minus x square will be x square. Finally its value will be 6x square. This is your determinant of this f dash x. That means f dash x value will be 6x square. Now if you want to verify this, here its value will be 6x square. Now I will tell you, suppose that if you want to verify this, is it correct or not, you can firstly find the value of determinant of this function, and thereafter you can differentiate. In both cases you will get same answer. Now again I want to take next question for you. See here, next question will be 52. See here, 52C. Sorry, not 52, 51. Sorry, 52. This is your 52. Fx is equal to there is given that fx is equal to determinant of cos x sin x cos x, sin x cos x, and the second row will be cos 2x sin 2x 2 cos 2x, cos 2x sin 2x, cos 2x sin 2x, and third integral will be 2 cos 2x, 2 cos 2x. In third row, cos 3x and 3x. You can write cos 3x sin 3x, and third integral again will be 3 cos 3x. Now you have to find the value of f dash pi by 2. What is the value of f dash pi by 2? Now sorry, you have to prove that value of f dash pi by 2 will be 4. You have to prove that f dash pi by 2 will be 4. See here, it is also very easy for you. But I will tell you, if you try to go solve this question after evaluating the value of fx, that means value of determinant, definitely it will be more lengthy for you, and you will definitely fall in trouble during solve this question. So I will suggest you firstly go through its property. Thereafter it becomes more easier for you. Firstly differentiate. As you know that derivative of this function, in that case firstly differentiate first row function. Here derivative of first row, cos x derivative will be minus sin x derivative will be cos x derivative will be minus sin x, and second and third row will be remains same, cos 2x sin 2x 2 cos 2x, and the third row will be cos 3x sin 3x, and it will be 3 cos 3x. I think you understand. Now take here second part. In second part you have to take cos x here, sin x and cos x. Now you have to differentiate second row, that means derivative of cos 2x will be minus 2 sin 2x, derivative of sin 2x will be 2 cos 2x, derivative of 2 cos 2x will be minus 4, sine 2x. I think you understand. And again here see, derivative of cos 3x will be minus 3 sine 3x. Derivative of sine 3x will be 3 times cos 3x, and derivative of 3 cos 3x will be minus 9 sine 3x. I think you understand. There will be minus 9 sine 3x. Now third part will be, see here, I want to write here third part. Third part will be simply write here first row, second row, and first and second row same. That means cos x sin x cos x, cos 2x sin 2x to cos 2x. Right here again, cos 2x sin 2x to cos 2x, and then differentiate third row. Derivative of cos 3x will be minus 3 sin 3x. Derivative of sin 3x will be 3 cos 3x. Derivative of 3 cos 3x will be minus 9 sin 3x. I think you understand. It will be minus 9 sin 3x. Now, see, you have to find f dash pi by 2 is equal to 4. I will suggest you again, sometimes students do mistakes in doing fast. That's why I will suggest you, if you try to evaluate its determinant, definitely it will be more complicated for you. Why? Because sorry, given function is in sin x, cos x, sin 3x, that means in multiple angle, different kinds of function, sin x multiple angle, some multiple and some multiple angle form. Definitely, if you will try to find determinant of this function, this determinant, it will be more complex one, because sin x, sin 2x, sin 3x will be in complex form. So I will suggest you, why not I want to put direct value of pi by 2 in this function, because you have to replace x by pi by 2. So I want to put pi by 2 in this function directly. In that case, you will get what? Write one here. F dash pi by 2 is equal to minus sin pi by 2, that means minus 1, minus cos pi by 2. Sorry, cos pi by 2 will be 0. Minus sin pi by 2 will be minus 1. Cos 2, that means here you can see cos 2 into pi by 2 will be cos pi. The value of cos pi, there will be what? Cos pi. Cos pi will be what? Minus 1. Sin pi will be what? 0. 2 cos 2x. What is the value of cos pi? Because 2 into, as you know that the cos pi will be what? Minus 1. So 2 into minus 2, 2 into minus 1 will be minus 2. Here you have to find cos 3 into pi by 2. That means you can calculate here if you not understand. Cos 3 pi by 2. So it will be cos pi plus pi by 2. It fall in third quadrant. So you can write cos theta is equal to what? Minus. In third quadrant, cos will be negative. So it will be minus cos pi by 2. As you know that it will be 0. So it will be 0. And similar way, sin 3 pi by 2. Sin 3 pi by 2, it will be again minus sin pi by 2. So it will be minus 1. And 3 into cos 3x. So it will be 0. Similar way, you have to again write here cos x. That means first row will be what? Cos pi by 2, cos pi by 2 0, sin pi by 2 1, cos pi by 2 will be 0. Now minus 2 sin 2x. What is the value of sin 2x? Sin pi is equal to what? Sin pi is equal to 0. If sin pi is equal to 0, minus 2 into 0 will be 0. 2 into cos pi. What is the value of cos pi? Cos pi is equal to minus 1. So 2 into minus 1 will be minus 2. And in third part, minus 4 into sin pi, it will be definitely again 0. In third row, if you see here, minus 3 sin 3x. I want to see here, I have done some mistakes. Sorry. Definitely I have done here some mistakes. Because here you have to differentiate only second row. And by mistake I have also differentiated third row. So I want to write similar as cos 3x sin 3x 3 cos 3x. I think you understand very well. Now cos 3x, cos 3 pi by 2. The value of cos 3 pi by 2 will be equal to what? Minus cos pi by 2. So its value will be 0. So you can write here 0. And sin 3 pi by 2 will be minus sin pi by 2. So it will be minus 1. And cos 3 again it will be 0. So it will be 0. Now its third part. You can see here. Third part will be. It will be what? Both will be same. So you can write here cos pi by 2 is equal to 0. Sin pi by 2 is equal to 1. Cos pi by 2 is equal to 0. Cos pi is equal to minus 1. Sin pi is equal to 0. 2 into cos 2, cos pi, 2 into cos pi, that means 2 into, see here, this is your 2 into cos pi, that means minus 2. Now this will be minus 3 into sin 3 pi by 2, that means sin 3 pi by 2 will be what? Minus sin 3 pi by 2 will be minus 1. So you can write minus 1 into minus 3, it will be 3. And 3 cos 3x, that means it will be definitely 0 because cos 3 pi by 2 cos 3 pi by 2 is equal to 0, so it will be 0. And this part will be again what? Minus 9 into minus 1, which will be 9. I think you understand very well. 1 second. See here. Its value as expressed in this form. It will be more easier for you. Now you have to simply find its determinant, and finally you put its value and you will get its correct answer. And I think its value will be see here, its value, you can go through this row and this column, it will be minus 1 times, both cancel, minus minus plus 2 and minus minus 1 plus, that means 2 minus 1, that means 1. And sorry, I think now you can do its value easily. Now you have to put its value easily, and this is the procedure through which you have to find the derivative of a different determinant functions. I think you understand. Now again take some different pattern question. Now you can find the determinant value and easily. Next question, see here. Here 53. This is also very easy question. Still I want to hint you because some notation you will confuse by taking it. Here it is given that if frx, you can write question, if frx, 1 minute wait. See here. Here it says to you, if frx, grx, hrx, these three functions, and hrx, it is given that, and hrx, such that r is equal to 1, 2, 3 maximum, are polynomial in x, are polynomial in x, are polynomial in x, such that FRA, GRA is equal to HRA is equal to HRA, and HR is equal to, and HRA and HR, that means here R is equal to 1, 2, 3, about which I have already told many times. Here you have to prove that there is also given fx, that means capital Fx is equal to f1x, f2x, f3x. In second row there is a different function g1x, right here, g1x, g2x, g3x, and in third row h1x, h2x, and h3x. It tells you prove that f dash a is equal to 0. It tells you you have to prove that f capital dash A will be 0. Now I want to solve it very easily. See here. Firstly differentiate definitely this function. According to property, firstly differentiate first function, definitely you will get f1 dash x, f2 dash x, f3 dash x. And in second row and third row functions written in same as your question. So there will be g1, g2, g3x, and there will be h1, h2x, h3x. And in second part again you can write f1x, f2x and f3x and differentiate g1 dash x, g2 dash x and g3 dash x, and write third row again same as your question. Now in third part again differentiate third row, that means h1 dash x, h1 dash x. Is it visible for you in downward portion? It's here. h1 dash x, h2 dash x, h3 dash x, and write second row same function g1x, g2x, g3x. Similar as write again same function in first row f1x, f2x, f3x as it is mentioned in your question. Now it is very tricky question. In your question it is given that FRA is equal to GRA is equal to HRA for R is equal to 1 to 3. Means that suppose that I want to put R is equal to 1. In that case F1A, G1A, H1A. Have you understood? See here. F1A, G1A, H1A. That means according to this question F1A is equal to G1A is equal to H1A. Similarly, if you put 2, it will be F2A, it will be G2A, it will be H2A. Similarly, F3A is equal to G3A is equal to S3A. I think you understand very well. Now, if you put in this question, as you know that you have to find the value of f dash x, sorry, f dash a, that means you have to replace x by a. So I want to put, I think you have written it. Now I want to find f dash a. That means you have to replace in f dash x, x by a. That means if you have to find f dash a, means that you have to put a in place of x. So I want to put here a. In that case, you will get f dash a. Here you will get f2 dash a. Here you will get f3 dash a, g1a, g2a, g3a. There will be h1a. There will be h2a. There will be h3a. Similarly, there will be f1a. There will be f2a. There will be f3a. Similarly, there will be again g1 dash a, g2a, g3a, g2 dash a, g3 dash a. There will be h1a, h2a, h3a. Similarly, you can write here f1a, f2a, f3a. There will be g1a, g2a, g3a, and it will be your h1 dash a, h2 dash a, h3 dash a. I think you understand very well. Simply, as you in your question it is mentioned, you have to find f dash a. So definitely you have to replace in f dash x, x by a. So I have put here a in place of x. Simply thereafter you will get these expressions. Now you have to find determinant of it. As you know that f1a is equal to g1a is equal to h1a, f2a is equal to g2a, h2a. Similarly, f3a is equal to g3a, h3a. As I have just told you, if in any determinant ratio of two rows increase to corresponding rows corresponding increase will be constant. That means fixed value. In that case, its determinant will be 0. As you know that here g1a, sorry, everyone I have written f1, sorry, this will be h, there should be h. By mistake I have written it f1, g1, h1, f2, sorry, this is also correct, f3, this is correct, sorry, by mistake I have written, see here, this will be g1a, g2a, g3a, this will be h1a. Now, see here, where is g1? g1, h1. If you take ratio g1a by h1, g1a by h1, if it will taken here in denominator, it will be 1, its ratio. Similarly, g1a upon h1a, it will be 1. If you take ratio g2a upon h2a, if you take g2a upon h2a, G2A upon H2A. Similarly, G2A upon H2A, which will be again 1. Similarly, G3A upon H3A will be again 1. That's why its value will be what? 0. What is the value of it? Again 0. Why? Because similarly, you can take F1A upon H1A. F1A upon H1A. F1A upon H1A. In that case, it will be 1. Similar way, F2A upon H2A. Similar way, F3A upon H3A. Definitely, it will give you simply 0. So, its value will be 0 plus 0 plus 0 is equal to 0. Similarly, F1A upon H1, G1A, F2A upon H2A, G2A will be 1, F3 upon G3 upon A. As I have already told you, if any determinant, if in given determinant expression in 2 rows or 2 columns, the ratio of its corresponding entries or elements will be constant or same, in that case its determinant will be simply 0. Have you understood? Now if you not understand this property, I want to write, but I want to rub this portion because I think you understand, and if you confuse, definitely you will confuse in its determinant property. So I want to hint what is the determinant property that will be used here. It's in evaluating this determinant. See here, what is that determinant property? See here, I have told you, suppose the determinant of A is equal to 2, 4, 6. There will be 8, 20, 16, 24, 1, 2, 3. Now, I want to tell you, suppose that you have to find the determinant of A. What is the value of determinant of A? Definitely you can go through your simple method, that means by breaking row or column. But I will suggest you, if you see here, it's 2 first row and second row, it's if you take a ratio of first row and second row corresponding entries, which will be above and below, that means 2 upon 8 will be 1 upon 4, 4 upon 16, 1 upon 4, 6 upon 24 will be 1 upon 4. In that case, as you know that here ratio of 2 rows entries will be constant, so without going anywhere, directly you can write its determinant will be 0. This is very important property. Sometimes it will be very helpful for you. So I have explained it. I think you understand very well. Now I want to take next question for you again. Next question is very interesting for you. See here, what is your next question? In next question, it has told you if fx, that means if this is your first question, if small fx is equal to sec theta. I think this question may be asked in your examination as your objective. So try to see this question. How can you solve in your examination? Sec theta tan square theta 1 theta into sec x. There will be 10x x 1 10x minus tan theta. There will be 0. Then you have to find f dash theta is equal to 1. Then find the value of f dash theta. And in this question, it is also given your problem. Option A is equal to 0, B is equal to minus 1, C is equal to independent of theta. Independent theta, and D will be none of D. See here. How can you find f dash theta? I want to tell you before starting this question. Here in this question, it has told you you have to find f dash theta. Definitely theta will be any constant. As I have already told you, if in your given expression, without mentioning it has used any arbitrary terms, definitely try to take as a constant. So that's why here theta will be constant. So sec theta is constant, tan theta is constant, this theta is also constant, tan theta is also constant. Be careful here, otherwise everything is okay. Here you have to differentiate fx. So this function is a function of x. So you have to simply differentiate this function in terms of with respect to x. and you have to, there after differentiating you have to replace x by theta. That will give you some particular value or any value. According to obtained value, you have to choose your given options. So see here, firstly right here, differentiate this function f dash x. After differentiating, its derivative will be 0. Why? Don't fall in trouble, because sec theta is a constant. Definitely, suppose that theta is a constant, maybe 45 degree, 60 degree, any value. Suppose that theta is equal to pi by 4, definitely its value will be what? Root 2. So I will always tell you, whenever you, so not about to any constant value, suppose that this is your 10 square theta. This is your 10 square theta, and if you put 10 pi by 4, its value will be 1, 1 square will be 1. So this is your constant, this is your constant, this is your SO constant. So during differentiating, try to take as a constant. Don't take, sometimes the students in follow differentiate it and write here sec theta into tan theta, because you have not differentiated with respect to theta, you have to differentiate with respect to x. That's why other than x, all terms other than x, that means other than function of x, you have to treat all terms or functions as a constant. So sec theta derivative 0. Similarly, derivative of tan square theta will be 0. 1 derivative 0. You have to take constant theta. Theta is a constant. Derivative of sec x with respect to theta x, it will be sec x into tan x. Theta is a constant, so I have taken here out of that means as a multiplication, as a constant. Derivative of tan x will be sec square x, and derivative of x will be 1. So you can write here derivative of 1 will be 0. Derivative of tan x minus tan theta will be what? You can write derivative of tan x is equal to what? Sec square x, and derivative of 0 is equal to 0. Now second part, you have to take same as sec theta tan square theta 1, and if you differentiate it, it will be theta into, sorry, I have again done some mistakes. It will be theta into sec x. It will be your tan x, and this will be your x. By mistake, I have differentiated one function in order. This will be tan x minus tan theta. It will be 0. Now, in second part, you have to differentiate second row in functions only. This will be theta into sec x, and you have to differentiate. If you differentiate sec x, its derivative will be sec x into tan x, and derivative of tan x is equal to what? Sec square x, and derivative of x is equal to 1. Now it will derivative of, it will be 1 tan x minus tan theta. Derivative of 0 will be, sorry, don't take tan x minus tan theta, sorry, everything is okay. 0 sec x into tan x is equal to sec x, sorry. Now I want to again differentiate third row. So firstly write same as sec, first and second row, sec theta tan square theta 1 theta into sec x tan x x. Derivative of this row will be 0, and its derivative will be sec square x, simply minus 0 and 0. Now you have to find its value. Definitely its determinant will be what? 0. And what is the value of this determinant? Simply try to use your expand simply through this rule. If you expand it, 1 this cancel, and then tan x minus tan theta, or you can go through anywhere. Don't bother by taking it. You have to simply if you go through this way, 1 definitely it will be what? It will be cancelled. It will be cancelled. Tan x minus tan theta into theta into sec tan x. Right here, tan x minus tan theta. There is no space, so I want to here. See here, I want to write here tan x minus tan theta into theta into sec x into tan x. I think you understand. Minus, actually its determinant will be 0, so I don't like to write here. And in second, in this row it will be minus. Firstly write here minus, and this minus, this both cancel. Tan x minus tan theta into sec theta. Right here again minus tan x minus tan theta. Tan x minus tan theta, tan x minus tan theta into sec theta minus minus tan square theta. uh, there will be also sec square x. I have do not written sec square x because if you expand along third column, it will be cancelled. Its product will be tan x minus tan theta into theta into sec x into tan x, about which I have written, and sec square x. This is correct. Similarly, this is correct. Now again expand through this rule. I think this will be cancelled, and simply you have to expand 32 into that means sec square x. This will be cancelled. This will be cancelled. X into sec theta. That means simply write here minus sec square theta into sec square x into. Now I want to again tell you, sorry, by mistake I have calculated it, but I have to also do some smart calculation, because you have to put f dash theta. I have not cared there. You have to put f dash theta. So firstly put here theta, f dash theta. This will be f theta into sec theta. This will be tan theta. This will be theta. This will be again tan theta, and this is correct. You have to write it sec theta into tan theta, and this will be your again sec square theta, and this will be tan theta. I think you understand. Similarly, you have to write again sec theta. There will be tan theta. There will be theta, and this will be your sec square theta. Now its determinant will be 0. Its determinant will be again 0. Why? Because not 0. Sorry, not 0. This its determinant will be not 0. What will be its determinant? Right here again. You have to expand along which function, because tan theta minus tan theta will be 0. So you can write here 0, and it will be, you have to expand through this where tan square theta minus sec square. It's simply, so it will be, its value will be tan square theta minus sec square theta, and here its value will be sec square theta minus sec square theta into sec square theta into sec theta into tan theta, sec theta into tan theta, sec theta into tan, minus tan square theta into theta into sec theta, minus tan square theta into tan square theta minus theta into tan square theta into sec theta. Now you have to calculate simply. Thereafter you will get definitely this is your tan square theta, this is your minus sec square theta, and if you multiply this function, this sec square theta, it will be sec cube theta into tan theta, and this will be your sec cube theta into tan square theta into theta. Overall, if you see this obtained value, you will definitely tell me totally obtained f dash theta is depends on theta. Why? Because it is a function of theta. Here all expression is relevant to theta. If you change the value of theta, its value also changes. So its value, that means f dash theta, depends on theta. So neither 0 nor minus 1, you cannot tell independent of theta, because if you change value of theta, definitely its value will also change. If its value will be either constant, suppose that 2, 3, minus 5, 0, in that case it will be independent of theta. But you got a particular specific expression in which theta is involved. That's why you cannot tell here it is independent of theta, and there should be answer. It will be D. So I think this is your correct answer. Now I want to take again next question for you. See here. Next question is, again there is another question which is also easy for you. See, next question is here. Final question here, second. Sorry, pen is ended. 1 minute wait. See, if y is equal to fx gx hx, fx gx hx, and element ABC, and you have to prove that dy dx is equal to f dash x, g dash x, h dash x, lmn abc. You have to find the dy dx. Now you will tell how can you find its value and how can you proceed. Definitely you will try to go through simple way. That means you have to firstly find the determinant of this function and differentiate, but do not go through that way. I will give you go that way, which will be your conceptual and very tricky. See here, as I have already told you, if in your given question there is no mention about given any particular terms, as you have they have used LMN, this is your N, this is your N, LMN, ABC. About it has not told anything. That means this is constant or variable. This is not, there is no any mentioning in. So always treat LM and ABC as a constant. So now it will be very easy for you. Derivative of f dash x will be, firstly differentiate first row, its value will be f dash x, g dash x, h dash x, and take LM and ABC as a similar question. I think you understand plus. Now you have to take fx, gx, hx and differentiate second row increase, its derivative will be 0 0 0 and third row increase will be ABC. Similarly in third row, fx, gx, hx, it will be lmn, and in third row its derivative will be 0 0 0. As you know that if any determinant each entry of any row or column will be 0, then in that case its determinant will be 0. So its determinant will be 0. So its determinant will be 0. Finally you will get what? Determinant of f dash x, g dash x, h dash x, lmn ab, lmn, abc. This is your correct answer. I think you understand very well. Thanks all of you, and in next class I will again discuss with you next topic of this chapter, in which we discuss particularly how can you solve miscellaneous types problem, because in your examination most of the questions comes from your objective pattern. Definitely I will again discuss some different types of objective questions and miscellaneous questions in your next class, and thereafter finally I will discuss some different type problems. That means some questions relevant to functions, determinant and this property. That means differentiation, all those topics which will be very helpful for you in your examination point of view. Thanks all of you, and in next class I will again discuss firstly miscellaneous exercise. Thereafter I will discuss with you some different pattern questions which has asked in your, that means in possible examination for you. Thanks all of you. Bye.